Hello, and today I'm going to go over the questions 1 through 4 from our density lab so that you can compare what you did in small groups to what the right answer is, and really more important, uh, how you get to the right answer. So what I'm going to do, I'll start with number 1, and right over here says, what is your estimated mass of pea pebbles? And that's what we're calling the little gravel that we had. That would be used to fill a park trail that is 4 kilometers long by 2 meters wide and by 10 centimeters deep. So really what we need to do is, again, like always, examine what is the question asking us, what do we have, what do we need to find. So like I showed a lot in my class, I'm going to start with this triangle, this pyramid for density. And at the top, I have my mass, my density, and my volume. So if we look, what am I looking for? I'm looking for the mass. How much mass would all that gravel be? So I'm going right here. I'm looking for mass. And in particular, I want my answer to be in kilograms. So that's this right here. This is what I'm looking to find, my mass. Now, that's a little bit of information. I don't see anything that says meters squares cubed or milliliters or anything like that. However, I do have some dimensions. I have 4 kilometers by 2 meters by 10 centimeters. Well, that is all right, but if you notice, all of those units are going to get me, they're all different. And I want to have one particular unit. If I look up in the top left, I want my units to be in meters cubed. So I'm going to change all of these to meters. So that's going to be 4,000 meters times 2 meters times zero point 0.1 meter. And that information I can actually do on the calculator. I could even do that in my head. That's going to get me to be 800 meters cubed, okay? Or 8 times 10 to the second meters cubed. Well, then that means I've got this volume right here. I have 8 times 10 to the second meters cubed. So now I'm still looking for my mass. So I need to multiply it by density. It didn't give me density, but that's where our lab was. Our lab was to get the density there. So I go back, I look at my data, and right here, this number right here, 2.34, that's my data. That's my average density, I should say that. So 2.34 grams per milliliter. So if I look at that, I've got grams and milliliters, I got meters cubed, nothing's going to cancel out. And I want kilograms as my answer. So I have to do a little math gymnastics. What I need to do is change my grams per milliliter into kilograms per cubic centimeter. And if you look up at the top here, we give it that 1 meter cubed equals 10 to the 6 centimeters cubed. And then on the previous slide, we told you that milliliters equals cubic centimeters. So what I'm going to write down then is that I have 2.34 grams per centimeter cubed. Okay. What I want to do is then I want to change that to be kilograms per meter cubed. So let's go ahead and first put in my little conversion factor that we have 10 to the 6th centimeters cubed is equal to 1 meter cubed. And then also we have that I want to get rid of this grams here, so I'm going to put gram conversion on the bottom, that 10 to the third grams is equal to 1 kilogram. And now I can kind of cancel out units. I can cancel out my grams. I can cancel out my centimeters cubed. And so if I look here, I've got 10 to the third, 10 to the third. That really makes that, I'm going to cancel this out and cancel that out, 10 to the third. So it's going to be 2.34 times 10 to the third. And what unit is left? Kilograms. 2.34 times 10 to the third kilograms per meter cubed. And again, this is my density. Okay. Now, I have my density, I have my volume, so I just need to multiply those. 2 times, 2.34 times 10 to the third kilograms per meter cubed. And again, I'm going to multiply that times my volume, which is up here, 800 meters cubed. 8 times 10 to the second meters cubed. That equals. So then I just need to go to my calculator and type 2.34 times 8 equals 18.72. And since I have times 10 to the third and times 10 to the second, where'd that go? I'm going to add both of those. So it's going to be times 10 to the fifth, and that cancels out meters cubed, that cancels out kilograms. Now, I'm almost all the way there. Remember, in scientific notation, I just want to have the decimal right after that first digit. So I'm going to move it left one. So it's going to be 1.87 times 10 to the sixth kilograms. And that is my final answer.